So we are going with angle of friction. In this angle of friction, so I have considered an object on the surface, and generally there exists two forces: normal reaction force and weight will be acting downwards, normal reaction force will be acting upward. If I have some applied force on this object, there exists one more force called frictional force, right? So frictional force also come into play, right? Now here what I am doing, I am taking resultant of frictional force and normal reaction force. Okay, so the resultant of frictional force and normal reaction force will be diagonal in the diagonal direction. So this diagonal direction, whatever resultant force I have, it will be in this particular direction. Okay, so this is the resultant force of what? Normal reaction force and frictional force. This I am taking with some letter S. Okay, some react, because already R I have taken with normal. That's the reason I have taken some other letter S I am taking it. Now, here, angle of friction is what? The angle between this resultant and normal force. The angle between the resultant force and normal force, we are taking it as a angle of friction. Okay, resultant of what? The angle between resultant force of normal reaction force and frictional force to the normal reaction force is called angle of friction. Okay, the angle between resultant of normal reaction force and frictional force to the normal reaction force, we call it as the angle of friction. So if we write an expression for this angle, usually when we want to write angles, we will take tan theta only. So tan theta is equals to, what do we write here? So tan theta means opposite by adjacent. We have to write opposite side will come this, as this opposite in the frictional force are parallel. So opposite side will be our frictional force and adjacent will be our normal force. So F by R we will write. Okay. So F by R we will be writing for tan theta. Now, so from here, F is our what we call it as a normal reaction force we will take, and this F we will take it as when the applied force is there. So this is about to start the motion. At that situation, we will be taking. That means Fs maximum we will take. Fs maximum means what? Static friction maximum. Static friction maximum means, so it is limiting friction. So Fl also you can consider, or Fl by R I am taking. Okay. So the limiting friction by what do we take? This normal reaction force. Okay. Now, so limiting friction by normal reaction force can also be written as a frictional coefficient mu s. Okay, that means what? Tan theta can be written equal to mu s, because this is equal to mu s. Already we have written mu s, right? Now, so if we write an expression for theta, theta is equals to tan inverse of mu s. Will write it, static frictional coefficient. We are writing, right? Now, in this. Yes. So that is we got an expression for angle of friction. One more angle will be there, angle of repose. That also we will see here. Okay. And here, so resultant force exerted by surface on block. If we want to write, we write an expression for S. So what do we write? A resultant force expression. If we write a resultant force. Resultant force expression if you want to write resultant force in this. So as these two are mutually perpendicular, the frictional force and the normal reaction force, directly F is equals to, we can write it. Perpendicular forces are there, their resultant can be written as squares of them. So that is a F square plus R square we can write. Okay, because these two I am considering it as equal. Okay? Those two will be balanced in general. Or you can take FL also. Now, frictional force generally we will write it as mu into R. So let me take friction only, not to confuse. Frictional force plus other one is R, right? Normal reaction force whole square, right? So the friction whole square plus this is square. This is resultant. Okay, this we have done when we are doing parallelogram law of vector addition. their resultant we found. When angle between them is 90 degrees, directly we will get this expression. Okay. Now S is equals to F is what? Generally mu into R we have general expression. Okay. Because mu is equals to F by R, we will have F is directly proportional to normal reaction force that we have seen in the last class only. From there I am taking F expression. Okay. So mu into mg, I can write mu into mg for F square, it is plus R is what? R will be balanced by this weight. So that if we write, so what do we write? Mg will write it. Okay. Now, so mg square we will get. So this is the resultant force. Okay. Now, in this, so mg square in both the terms, mg square is common is there. I can take out mg out. So square root of mu square plus 1 we will write. Okay. When if I take out mu g as a common. Now, so in this. So when there is no friction, when there is no friction between these two surfaces, what happens? Mu becomes 0. When mu becomes 0, so this only square root of 1 will be there. So we will get end up with only mg. So the resultant force becomes only mg. So when there is no friction, what happens? So this is extra condition only. This won't happen generally, but we are imposing one condition. So if no friction, there is no friction. So what happens if there is no friction? Frictional coefficient of friction becomes 0. That implies S becomes equals to mg. This is general. In general, it is not applicable. It is an ideal case which we are imposing. So in that case, so if we write an expression for S resultant force expression if we write. So what do we get? We will get resultant force will be lying in between mg is less than or equal to, resultant force is less than or equals to mg square root of mu square plus 1. So the resultant force lies in between. The resultant force lies in between mg and mg square root of mu square plus 1 value. Okay. So the resultant force lies in between them. Okay. So that is about angular friction and the resultant force between friction and normal reaction force. And I said one more thing, that is angle of repose. Angle of friction we completed, and we will go with the angle of repose. Angle of repose is what? So angle of repose we will define when the plane which we have taken, when the object, whatever we have taken the object, if it is on inclined plane, the object is an inclined plane, then we will go with this. That means, so if this is our normal surface, right? Whatever we have taken previously. So, and I am wanted to take one inclined plane. I have taken now inclined plane. Now on this inclined plane, our object is lying. Okay? Same object, whatever I have considered over there, that object I am taking. Right? So this is our object. Previously, the same object I have taken. Now, so what are all the forces acting on it generally? So weight will act downwards, right? So weight is acting downwards, and normal reaction force always acts on the perpendicular to the surface, right? So from here only let me consider, so that will be easy, right? So this is our normal reaction force. Next, so applied force if it is in this particular direction. Next one is what? Frictional force will be there. Frictional force will act in this particular direction, and this weight is nothing but our mg, right? So weight is nothing but mg, and this mg I am resolving it into two components. If this angle is alpha, so automatically this angle also becomes alpha. Yes, this will become alpha. So mg adjacent side, this is mg sine theta. Okay, sorry, mg adjacent will be cos, right? So mg cos, angle here is alpha, so we will write it as alpha, and one more component will come. This is horizontal component, this is a vertical component to this angle. Okay, now this becomes mg sine alpha, right? Only this weight only I resolved into two components. This is our normal reaction force. Now here we have to define the angle of repose. Angle of repose is defined as angle of inclined plane with the horizontal such that a body placed on it just begins to slide. That means when the body is about to slide down, whatever angle is made at this inclination, at this inclined plane, that angle we take it as angle of repose. Okay. So if we write an expression for this under limiting friction condition. Okay. When it is when it is about to start means we will get friction called a limiting friction. So when limiting friction comes into play. So when the object is at rest, static friction. When the object is about to move, limiting friction comes. When the object is moving means kinetic friction. So we are defining this angle of repose. So what we are defining, angle of repose. Angle of repose, when we are defining, we will impose one condition that, so when the object is about to slide, at that situation, whatever angle is made with inclination, that angle we are calling it as the angle of repose. Now, here limiting friction role is played by, here limiting friction acts. That limiting friction is role is played by mg sine alpha. Okay, so because it is acting this way, so that when I am resolving mg into two components, mg sine alpha is acting this side. So which one acts actually this side? Friction. Which friction? Limiting friction. So that limiting friction is role is played by mg sine alpha. So now our limiting friction value is mg sine alpha, and limiting friction value mg sine alpha. So friction value we got here. And what about a normal reaction force? Normal reaction force role is played by mg cos alpha. Okay. Now, if I write an expression for this f by r, this f by r, if I write, so what do we get? Mg sine alpha by mg cos alpha. So alpha it is. So mg, if it is cancelled out, we'll get sine alpha by cos alpha. Sine by cos, it is the tan alpha. Tan alpha is equals to limiting friction by normal reaction force we got. And in this, already we have limiting friction by normal reaction force. We got it as a static frictional coefficient. So again, tan alpha is equals to, we got it as mu s, right? Now, and previously also we got to tan theta is equals to tan alpha we got. Sorry, tan theta is equals to mu s we got. When we are defining angle of angle of friction, when we are defining angle of friction, we indicated with the theta. The theta also, tan theta also we got it as mu s, right? So mu s is equals to, already we got tan theta. That means what? Tan alpha is equals to tan theta we got, right? From this expression, what we can write? Tan alpha is equals to plus tan alpha is equals to tan theta. So that means what? That is alpha is equals to theta. So what we can say from this, angle of repose is equals to angle of friction. So just to differentiate angles, I have taken here alpha. Okay. So angle of repose is equals to angle of friction we got over here. Okay. Right. Now, in this, so what we can say, the coefficient of limiting friction is equal to tangent of angle of repose and tangent of angle of friction. Okay. Now, so that angle of repose and angle of friction, they will ask us to prove equal. So for that, what we have to do, we will have to write angle of friction and angle of repose. Then we will be ending up with this statement, so that in the end, in the conclusion, we will write, so the angle of repose and angle of friction are equal, we will mention. Okay. So that is about angle of friction and angle of repose concept.